In this video, we're going to take a look at what are known as special methods in Python. Now, in short, special methods are very powerful inbuilt methods which you can use in order to create advanced classes. And seeing as we've covered the basics of classes, it's definitely worth covering special methods so that you understand how they can be useful in programming. Now, we've seen that when we create a class, we essentially create custom objects which can contain attributes which tell us something about the object, and methods which are functions defined inside of a class. And to access these attributes and methods, we can create an instance of the class and then use dot notation in order to access the respective functionality. We've also used inbuilt functions like len, for example, when working with strings and lists, and also sorted when working with lists. Now, Python allows you to support your own custom objects for inbuilt functions, just like len and sorted and many others. In other words, you can also make it so that these inbuilt functions work with your own custom objects too. You just need to implement some special methods to your respective class. Now, so far I've been saying special methods, but you'll also hear special methods termed as dunder methods because they contain the double underscores before and after the method name. They're also referred to as magic methods, but don't let this confuse you, they all relate to the same thing and have the same meaning. So what are special methods in Python? Well, special methods have a predefined syntax which is available to implement in our class. Now, the core data structures such as strings and lists also implement these special methods internally, which allow the respective objects to be compatible with many inbuilt functions. Now, to understand this better, let me first create a Python list which we'll label as my_list, and we'll set this equal to the integers 1 through to 5. Now, we've seen that we can call a built-in function known as len in order to find the amount of elements in this respective list object. So if we put len and then pass in my_list inside parentheses, we bring back the value 5 accordingly. So what does this mean? Well, it means that inside of the core data structures class, i.e. the lists class, there would have been a special method called len that was defined in order to allow us to call the len function on list objects. And to show you this in a different way, if I were to put the name of the object, in this case my_list, and then use dot notation to access the method, we can then put dunder len dunder with parentheses, and when I run this code cell, we also bring back 5. Now, what we're essentially doing here is using the special method or dunder method on this object to run the built-in len function. And the syntax in these two examples perform the exact same operation. Now, whenever we use an inbuilt function, it tries to find a predefined method that does the task, like len. So for example, the len function finds the dunder len dunder method in that object. So providing we have defined the dunder len dunder method in our own class definition, we can use the built-in len function. Very handy indeed. Now, it would be a very long video if I were to go through every special method that exists and explain what they're used for. So I'm not going to do that. But what I am going to do is highlight some of the more common ones and give you a foundational knowledge so that you can go and explore this concept further. So some of the more popular special methods would be things like dunder init dunder, and this is called when the object is initialized. And we've been using this special method when defining our class. The dunder rep_r dunder method is also a very common special method as it returns a string when we print an object. Now, this is usually intended for developers in order to debug, but once again we'd need to define the dunder rep_r dunder function in order for us to be able to call the built-in rep_r function. We also have the dunder str dunder function, which is the built-in str function, and what this means is that when we put print and then pass in the object name, it will print out a nicely formatted string to the screen. Now you may be thinking this sounds very similar to that repr dunder function that you've just mentioned. Well, it is, but if the str special method is not implemented, the repr dunder method will be used as a fallback. We also have the dunder del dunder method, and this essentially allows us to use the del built-in function, and when we call this, the object itself will be destroyed, and we'll see this shortly in an example. We can use the dunder lt dunder method, which stands for less than, which enables us then to use that less than operator. We can use the less than or equal to operator if we implement the dunder le dunder method. There are also special methods for the comparison operator, does not equal operator, greater than and equal to, and I'm showing these on screen now. If we wanted to be able to use the plus operator, so for example we can use the plus operator when concatenating strings, or when we use the plus operator when using integers, it will add them together. All we need to do is implement the dunder add dunder special method. The dunder sub dunder special method will enable us to use the subtraction symbol. If we wanted to use star syntax, we could implement the dunder mul dunder, which stands for multiply. We have special methods that allow us to use the built-in int function and the built-in float function. We'll see this shortly. We have the dunder len dunder function, which will enable us to use the len function. We also have two known as iter and next, and you'll see both of these when we cover iterators within the section that covers generators. Now it's very easy to use special methods in our own classes. They will essentially extend the functionality of the class by making them compatible with inbuilt Python functions. Now it's worth noting that it's not necessary and sometimes not even possible to implement every special method in every class. So you'll need to think about the object that the class is representing and establish whether the special method is appropriate in that use case. So let's go ahead and create our own class in which we'll define some of the special methods I've just mentioned. And what this class will do is essentially represent an individual's bank account. It will tell us who owns the bank account and what the balance is on the account. So we'll put class and we'll call this class bank account. We can then put a colon. We will then define our init method, so we'll put def dunder init dunder, and in parentheses we're going to pass in self, and we're also going to pass in two attributes, one called name and one called balance, and we'll default this balance to be 0 in the event that no balance is passed in when creating an instance of this class. We can then put a colon. We can then state that self.name is equal to name, and then self.balance is equal to balance. What this means is we'll be able to use dot notation and then call upon the name attribute and the balance attribute to bring back the respective values accordingly. And just to prove that the dunder init dunder method executes upon constructing the object, we're also going to print to the screen a little message that states dunder init dunder account created with then curly braces balance. We can then use the format method, and then we will pass in self.balance inside parentheses. We'll also create a very simple method called getBalance, which strictly speaking isn't required because we are able to call upon the attribute, but we'll put def getBalance and pass in self, and we'll simply return self.balance. So this means now that we can call a method called getBalance, and we can put parentheses. When we then call this method on an instance of this class, it will then show us that respective balance. Let's now include some special methods. So the first special method that we'll include will be the dunder repr dunder method. So we'll put def dunder repr dunder, and in parentheses we'll pass in self, and then we're simply just going to return a string which states dunder repr dunder. We'll then put the word account, and in brackets we'll pass in two curly braces separated by a comma. We can then use the .format method, and we'll pass in self.name and self.balance. We'll then implement the dunder str dunder method. So we can put def dunder str dunder, pass in self, and when we call upon the built-in str function, we want it to return a string which states dunder str dunder, then we'll put account name equals and then curly braces. We'll then put a comma. We'll put account balance equals and then curly braces. We'll then use the .format method and we'll pass in self.name as the first argument and self.balance as the second argument. Now let's suppose that we want the user to be able to convert the balance into an integer and also convert the balance into a floating point number. So we'll first of all put def dunder int dunder, then pass in self, we'll then put a colon, and we want the built-in int function to simply return the int of self.balance. We can then copy and paste this code, and what we're going to do here, in order for us to be able to use the built-in float function, we're going to change the word int to float, and we want to return the float of self.balance. So let's add two more special methods. Let's suppose that we want to see whether one account is less than another account, with these two accounts being an instance of the bank account class. So we'll define the dunder lt dunder method, which stands for less than, and we'll first of all pass in self, and this specific special method requires a second parameter, and we'll simply label this as object, so obj. We'll then put a colon, and first of all we want to try a statement which will try to return self.balance is less than obj, and then we'll place a dot and access the getBalance method. We can then put parentheses. Now if this runs into an exception, it's likely that two accounts are not being used, so we'll simply return the string, are you sure you are comparing two bank accounts? That will do for our less than special method. And finally, we want to be able to use the del inbuilt method, so we'll define dunder del dunder, we'll pass in self, we'll then put self.balance equals 0, and then we will print to the screen dunder del dunder account deleted. And I think that will do for now for this class. We've included many special methods here, so let's see them in action. So first of all, we're going to create two instances of our bank account class. The first instance will be called Deans_account, and we're going to set this equal to a call on the bank account class, and in parentheses we're going to pass in the person's name, in this case it's Dean. We'll then put a comma, and the second attribute relates to the balance of the account, so we'll simply pass in 1000. We'll then create a second instance called Sams_account, and we'll set this equal to a call on the bank account class. The first attribute will be Sam, and the second attribute will be 2500. When I run this code cell, you can see that we print two lines to the screen, and that's because the init method is called when the object is initialized. And because we've got a print statement in here, we've printed two lines to the screen, one which states account created with 1000 balance, and the second account created with 2500 balance, just like we would expect. If I wanted to get the balance on Dean's account, I could put Deans_account, place a dot, I can then access the methods. The method I want to call is the getBalance method, so if I select getBalance and put parentheses, you can see when I run this code cell, we bring back 1000, which is the balance on Dean's account. We also have the built-in str function and the built-in repr function, so let's print to the screen a call on the str function, and inside parentheses we'll pass in Sam's account. On the second line we'll print to the screen a call on the repr function, and we'll pass in Deans_account. When I run this code cell, you can see that the first print statement is printing out account name equals Sam, account balance equals 2,500, and this is because we've defined the string in this format when defining the dunder strdunder method, and when we defined the dunder repr_dunder method, we simply returned the string in a slightly different format. Now if underneath these two print statements I simply print and in brackets pass in the object name Deans_account, we get the same format as the dunder strdunder method, and this is because the implementation of the dunder strdunder method will be the result of printing the object, which gives us that nicely formatted string. If the str special method was not implemented, the repr special method would have been printed to the screen. We can call the built-in int function, so if we put int and pass in Sam's_account, we get 2,500 returned as an integer. If I put float and then pass in Deans_account, we get 1000.0, so we get a floating point number returned. I can use the less than symbol, so if I put Deans_account is less than Sam's_account, and note that these two objects are an instance of the same class. When I do this, we bring back true because Dean's account has 1000 and Sam's account has 2500. If I wanted to, I could call upon the built-in del function because we've defined the special method dunder del dunder. So if I put del and in brackets pass in Sam's_account, we print to the screen dunder del dunder account deleted. And if I now try to simply print out Sam's_account, which we would expect to be that dunder strdunder method, we actually run into a name error now, telling us that the name Sam's_account is not defined, just like we would expect because we've just deleted that specific object. So hopefully you can see the benefits of incorporating dunder methods in your class definitions. They provide you with even more powerful custom classes on which you can call built-in functions to perform a specific task. This may be bringing back learnings from the polymorphism concept that we visited in the last video. They essentially give you the ability to create your own custom classes that actually behave like native data structures, such as lists, tuples, dictionaries, sets, and so on, as you can actually share the built-in functions that we've been using across different object types. Now, a simple benefit of special methods in Python is that we do not need to remember individual methods of any object to do any task. We just need to know that we can call a common method to perform the task, and it will work on our own objects providing we have defined them. For example, using the dunder len dunder method would be much easier to remember than creating your own method called length, for example, which essentially performs the same task. Now, seeing as len is a common convention, it would be much easier to remember. So a couple of summary points to keep in mind. Dunder methods, special methods, or the term magic methods relate to the same thing, so don't think that these are different concepts. Dunder methods make our classes compatible with inbuilt functions such as len, int, float, and so on. By implementing special methods, a user wouldn't need to remember each and every method which pertains to a specific object that then performs a specific task. We just need to use inbuilt functions and pass the object inside the parameters. This makes Python's syntax much more consistent and easy to read, and I'm sure you'll agree, easier to remember. In the next section, we're going to be covering the world of modules and packages, which is an exciting topic, so I'll see you there.